Okay, I had a couple students that asked me questions about what do I do when I start with liters as opposed to grams, like many other questions. And we're just going to take a couple minutes and go through a question that's similar to one of the questions on the assignments. So this one here says hydrogen phosphate gas is combined with oxygen gas to produce phosphorus oxide gas and water vapor. If there is 59.2 liters of oxygen available, what volume of hydrogen phosphate gas may be combusted if the pressure is held constant at 110 kilopascals and the temperature is held constant at 210 Celsius? So what I did to kind of help us out here is wrote out the first couple of steps that you need to do whenever approaching any of these questions. Okay, so step one is write a balanced chemical equation. Okay, so I'm just going to step away from the mic while I write it. Alright, so there's the equation there. H3P plus O2 goes to P2O4 plus water vapor. Okay, so this is the equation, but we need to actually balance it, because if we don't balance it, everything else will actually be wrong from this point. So I'm just going to choose a different color. Okay, and so I start with my hydrogen, and look at my hydrogen and see that there is 3 hydrogen on the reactant side and 2 hydrogen on the product side. Okay, so I put a 2 and a 3. Alright, and then I look at my phosphate now, and see that now that I put that 2 in front of the H3P, I have 2 phosphate and 2 phosphate, so they're balanced. Alright, and now I look at my oxygen. Okay, I got 2 oxygen on the reactant side, and in total 7 oxygen on the product side. So I can't write 7 over 2. Okay, so how I fix this is I double up all the numbers that exist there now. I'll just fix the other ones.
Hey, I forgot to remind you to tell Mary at 3:30 what you were doing this morning. Okay, perfect.
Okay, so
Okay, thanks.
double them all up.
Okay, bye.
Oops. Okay, so now I have 6 oxygen in the water, 8 oxygen in the phosphorus oxide, and so I need to balance the 8 oxygen in groups of 2 with the oxygen gas. Alright, so now we have a balanced chemical equation, and our next step is to find the mole ratio of what we want. So we look back on the question and we see that we're starting with oxygen, okay, but it's asking us hydrogen phosphate. Okay. Alright, so we see here that our ratio is in a ratio of 4 to 4. Okay, we're going to use that later, just not right this second. Alright, and now our next step is to calculate the moles of oxygen using the PV equals nRT. So I'm just going to step away to write that now. Alright. Alright, so there's my equation there. Alright, so now I pull up my calculator. And go 110 times 59.2 divided by 8.314 divided by 483 equals 1.62. Okay, so 1.62, I'm just going to erase that for a second. Uh, 16504. Okay, so I'm carrying a couple more decimals than I need. Alright, so my next step is to apply the mole ratio. Alright, so in this example it may seem a little silly to do that calculation, but it's important to show you exactly how I'm getting that number. I transferred from moles of oxygen to moles of H3P, and now my next step is to actually take my new number now and kind of go back through and calculate my volume. Alright, so it's the same calculation as it is here, just going kind of backwards. If you have any questions, just email me, your teacher, and Have a great day. Bye.